So for part 2 of this unit, we are going to talk about how we simplify square roots. And this is really the majority of the operation that we are going to perform in this lab. We won't start doing, addition of square roots or multiplication of square roots or anything like that until we get later down the line. So all you're going to be asked to do for this lab is simplify, but you have to understand what that means. So in math, when we want to reduce an expression to its lowest terms, we say simplify. Much like you would do with a fraction, right? If I said, how do you simplify 4/8? Well, you can reduce that to 1/2. You can do the same thing with radicals. Our goal is to have the smallest number possible left inside the radical or left inside the house when we're done simplifying. So how do we figure out how to simplify a radical? This is why that first video about vocab was important, because this is going to be all about factors. When we're talking about simplifying a square root, you have two possibilities. You either have a perfect square, which is going to be easy, or you have a number that you need to find the factors. Okay? This is an or situation. You either have a perfect square or you're going to have to find the factors. So if you're given a perfect square and asked to simplify, well, that's very simple. This is why having that chart out is important. If I give you the square root of 25, I know that this is a perfect square, and I know the square root is 5 because its two factors are 5 times 5. So simplifying a perfect square, the radical disappears and all you have is the factor left over, or the square root, okay? But let's say your number inside the radical is not a perfect square. Then you're going to have to find the factors, okay? So you'll have a number that you can break up into two factors. The square root of A times the square root of B. And when you're breaking your radicand up into the two factors, A should always be the biggest perfect square possible that will evenly divide into whatever your radicand is. And then B is just the other factor that you're multiplying A by to get the radicand. Okay? So let's actually walk through an example, and then I'll make this a lot easier. We are being asked to simplify the square root of 27. So you'll check your perfect squares table. 27 is not a perfect square, so we have to break this down into two factors. Let's think about what our factors of 27 are. 1 times 27, we already know that that's not a perfect square, so we're not going to use that grouping. 27 can't be evenly divided by 2. What about 3? 3 times 9 is 27. And we can stop right there because if we're looking at our table, we know that 9 is a perfect square. So these are the two factors that we're going to pick when we take the square root of 27 and rewrite it as the square root of 9 times the square root of 3. Okay? So now I like to use a little table, like a little chart, for breaking these things down, because we're going to keep going with this factor idea. I'm going to organize a little chart, and one side is going to be the side that comes out, and one side is going to be the side that stays in the radical. If I break down 9 into its two factors, into its square roots, right? Those things match. When you have a twin set of factors like that, when you have a square root, that's what's going to come outside of the radical. Just like with square root of 25. The square root of 25 is 5, so that made the radical disappear completely. If you've got a pair, it will come outside of the house, like they're going on a date. They've got each other, they're going to leave the house, they're going to go whatever, to the movies. But the square root of 3, the only factors of 3 that we have are 3 and 1. There's no pair there. There's no matching factors. So 3 is going to stay home alone by itself and watch Netflix or something sad. Okay? So you need to have a pair to move outside of the house, and anything that doesn't have a matching set of factors has to stay in. So when we're organizing this little table, and this will become much more necessary when we have a bunch of variables with exponents to use, I know the perfect square is going to come out and the other thing is going to stay in. So I can keep myself organized and say, well, whatever's on the left, that'll square out. That's going to come to the outside, right? The square root of 9 squares out to 3 and 3. So 3 comes outside. With those identical factors, you only have to write the number once, right? You wouldn't take 9 outside. You take the square root outside of the radical. Okay, and then the square root of 3 stays. 3 stays inside the house because it doesn't have a buddy. Which means our answer will be this 3 times the square root of 3. Now in the fourth step, I say any coefficients because you need to look if the problem that you are given includes a coefficient outside of the radical, then you will multiply the square root, which is the thing that came outside, by any coefficient, anything that's already out there. And we'll look at a couple examples to figure that out. Okay, so I asked you a question down here. What happens if the radicand is a perfect square? Do you remember? What happens with the actual radical if the only thing inside is a perfect square? You've got those two matching factors. You know that since they're a pair, they get to move outside. Well, now there's nothing else left to stay inside. So that means that the radical disappears. If you have nothing left to keep inside, then there's no point in having the house. It will crumble. Okay? And you'll have nothing. You'll just have the square root answer. So let's look at a couple examples. Okay? The square root of 60. Check your table. Is 60 a perfect square? No, it is not. So we know we're going to have to break it down. And we're going to break 60 down to two factors, one that will come outside and one that will stay inside the radical. The one that will come outside has to be a perfect square. So let's think about what our factors of 60 are. 1 times 60, well, we know it's not that. 2 times 30, 3 times 20, 4 times 15. 4 is the biggest and only perfect square that will divide evenly into 60. So we know that the square root of 4 is what will come outside, and 15, square root of 15, will stay inside. Let's double check just to make sure. If I break 4 down into its factors, 2 times 2, that matches, so we know that 2 will come out. 15, if I break that down into its factors, I've got 3 times 5. Those things do not match, so 15 will stay as it is inside the radical. I'm simplifying the square root of 60 to have the smallest number possible left inside. All right, let's try 144. Check your table. Is 144 a perfect square? Yes, it is. And we can break it down to the two matching factors of 12 and 12. which means that 12 is the square root of 144. There is nothing left inside the radical, so the radical disappears, and our answer is just 12. All right, and last but not least, let's check out 2 times the square root of 45. 45 is not a perfect square, so we're going to have to simplify that radical, and we already have the existing coefficient of 2. So let's make our little table of what's going to come outside and what's going to stay in the radical. 2 is already outside, so we know it'll be outside. And then 45, how can we break that down? What are the factors of 45? 1 times 45. Oh, if we did 2, it would be a decimal. 3 times 15. No, can't divide it by 4. 5 times 9. Well, 9 is a perfect square, and it's the biggest perfect square that evenly divides into 45. So I know that the square root of 9, I'm going to put in the come out column, and the square root of 5 will stay inside. So the square root of 9, 3 times 3, we know that 3 will come out, and we know that 2 will come out, and 5 will stay inside. So that 2 that's already out there times the 3 we're bringing outside, and the 5 stays in. 2 times 3 is 6. So the simplified version of 2 times the square root of 45 is 6 times the square root of 5. Okay. Stop this video, rewind it, and watch it again, because this is complicated, and you guys need to know how to do this so that we can move on to part 3, which is simplifying cube roots. So give it a try and let me know how it goes.